recording for, well, I probably shouldn't tell, but for someone, it's super hard to tell if you look over there. But anyway, we'll just move on. So to do this, make sure you have your periodic table out and turn it to this side. This side is called the side with the electronegativities. It's the electronegativity table. Everyone touch it right now. So I know that you are with me right now. Touch that side. Or touch your neighbor's lab book. Sorry. All right. So if you were here Friday, you should be colored, correct? If you don't have colors, you can get those, like take a picture of it with your phone and do it at home, or that class video is online. It was my sub plan. If you ever miss a day that I'm gone, just look at behscience.com/sub and you'll have it. All right, here we go. So to review, in case you were gone, so Charity, me and you, are you ready? All right, anyone else? Here we go. One of the questions was asking you about lithium fluoride, or LiF. To do this process is very simple. Were you here Friday? Okay, so you'll probably be fine. You find these two numbers. These are your electronegativities. Everyone, point to your lab partner's electronegativities for fluorine, so I know you know, and then I'll feel better about myself. Fluorine, F. All right, so which one of those two is bigger, 4 or 0.9? 4. That was the easiest question in chemistry so far. You take the big and you subtract the small, 0.9, and you get 3.1. Now, that 3.1 is equal to what? Tell your labby right now, what is that equal to? Not the number, what does it mean? Okay, I heard one answer here. I heard some mumbling over there. What does it mean? It's 3.1 watts. That's a hard question, because in the video I said we don't care what it is, we just care that it's a value, right? It's our electronegativity value that we use on page 6, right? We go along the bottom. 3.1 is way over on the right side. What do we call the right side? Ionic bonds. Who had that right? Raise your hands. Closer? Does it make a little more sense? So you don't have that, but they're also listed right here. All right, then we had CO2. Pretend your lab partner was gone and tell them what you do with that 2. Right now, quick, 10 seconds. All right, Amelia, you were gone. You're sort of bugging me like you're not paying attention. Okay. So everyone tell Amelia what you do with that 2. You ignore it. All right, you ignore it. Because if you'll look, CO2 is this. It's an O, a C, and an O. The 2 is represented with 2 O's. Like we can see that with our eyes. But really, it's just made out of bonds between a C and an O. We don't care how many times it's bonded. We just care that it is bonded to a C and an O. Got me? All right. So we go back and we find carbon. And I'll stay here for a second. You tell me what carbon's value is. 2.5. Now, where did I find that? Where did you find that? Tell your labby. Charity, scoot over. Were you here Friday? Okay. That's not going to help. Now, listen to post. Everybody stay right where you were. You got to help her. She was gone. All right, oxygen, and you're helping? Reagan? Okay. What's oxygen? 3.5. So I'm going to subtract going that direction, whatever. What's the difference? 1. In science, triangle means 1. The difference is 1. Go to your graph. I don't know where it is. Eventually, I just went past it a mile, whatever. Go to your graph, and 1 is right here. What do we call these if they're greater than 0.6 and less than 1.7? Polar. So in bio, they taught you water's polar 100 times, right? And now we know why. It's because the electronegativity difference between an O and an H is greater than 0.6 and less than 1.7. Now that's a long answer, and it doesn't really mean much to you, but over the next couple of weeks it will. All right, let's make sure we do one more. I will leave this, well, you have your chart. Oh, come on, Tom. So let's pretend we had H2S. Those of you that were gone, do this on your very own and then ask your lab partner if you got it right. Which means lab partner, you better do it too, so you know whether it's right. H2S, find the type of bond. All right, and on page number 16, on the left side, it looks different. And that might be frustrating. When like I build all this knowledge and then I change one thing and you're like, I don't know what you're doing. Math is classic for that. So here we go. It looks different because it's drawn how they are built. This is called their structural formula versus just their molecular formula. But it doesn't matter. 37, the second column over says type of bonds. Do you see that? All right. What you need to do for each one of these is determine the type of bond by doing the math. When you get to 41, don't do anything. So the next 2 minutes, who did I steal this from? You? Oh, you. Okay, I apologize. I'm like so confused. For the next 2 minutes, will you silently see if you can determine the type of bonds in page 16? Then, after those 2 minutes, then discuss and check with your lab partner. If you both match, you're probably both right. So 2 minutes, ready, set, go. they're like, hey, this is the same structure. Put 8 around the middle and I'm done. That's what 8's being, but that is wrong.
this?
Yeah. You get new contacts?
My dog ate my contacts.
Yeah, I've heard that before.
Always.
Do you really have contacts?
No, I'm not having them. My dog ate them.
She's lying. She never had them.
Oh my gosh. Okay.
You did? Yes. Oh my gosh.
That's funny. If you've had Bert, he draws huge. I don't know why I did that. That hurt my shoulder. So BR, and then there was one other thing we need to make sure and do, and that is what? What else was there in the box? There was a line which represents how many electrons. Thank you, Breck. 1, 2. Now look, if you put them 1, 2, I don't care. It doesn't matter. So there's 1, 2 there. I put them that way just because I'm picky. All right, there's 2 in the middle. But that's the only thing the picture has shown you. So what else do you need? Each one needs 8. So each one needs how many more? 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Why is he listening to 1988 rock? What? Yeah, nothing says that. Like 80s love ballads. Bert and I have a song. Has he ever told you that? we have a song. Listen to Your Heart. That's our song. I have no idea. It just is. It came from fantasy football. Okay, who had that right? All right, are we ready? Do the very bottom one. NH3.
No, it's not.
It is. Did you say it's weird? Yeah. Were you blue last week? I swear it's different color. That was paused. That would have been. All right, here we go. Please with me. Shh. NH3 has one little sliver, and when you see it, you'll be like, oh yeah, I forgot. But it's not going to ruin your life. You have an N, an H, an H, and an H, correct? Then there are 3 lines. Shh. Each line represents what? 2 dots. 1, 2, 3, 4, 5, 6. What is up? Then almost everyone that was wrong did the following. They thought, all right, they're non-metals. They all need 8. Which is what I tell you. But sometimes I lie. Hydrogen, I don't know why it does that. Hydrogen's on the top row of the periodic table, which means it can have a maximum of how many dots? 2. Hydrogen's done. So to finish this, you just put 2 on the end. So the only exception to the octet rule is hydrogen and helium. And it's not really an octet rule if you look at the octet as though they all want to be like family 8. What? You didn't like it? What made you mad about this? Sorry. On the bonds? Yes.
Hydrogen, I thought that it only had that 1/2 of the bond. So give it 3 instead of 2.
Does it make sense now?
Yeah.
Okay. All right. The last one that would just be aluminum, but you'll notice it says Na, right? And that means non-applicable. We do not draw electron dot structures for metallic bonds because electrons don't live in a specific location in a metallic bond. They're free to move wherever they feel like. All right. I'm sure that went great. Let's turn back to page 3.
Yes.
Or maybe 4. Page 6. Actually, how about page 7? We'll work through it. Yeah. For the next day and a half, well, so far we've been using 3 terms when we discussed types of bonds. Do you know what they were? Oh, that was funny. I was so good till there. They are polar, nonpolar, and ionic. Those are the 3 types of bonds. Our goal over the next day and a half is to learn about them and their properties. I'm still talking. The first one we're going to have is an ionic bond. Now, if you'll, who has the, thank you. You have on page 6 this graph, correct? But you can't use that on your test. That would suck. But over here, that graph is written out in word form. So it says an ionic bond has an electronegativity difference of 1.7 or greater. Do you see that?
Yep.
All right. Thank you. You are the best right now. There will be 4 things that we write under ionic bonds that will tell us the properties. So this is what we'll do. I will give you a structure that will be already drawn. You determine the bond type using this, and then I will ask you what it dissolves in. If it's malleable or brittle, whether it conducts, and whether it has a high, medium, or low boiling point. Forever. Like at least 6 or 7 school days. Get out. Why are you still here?